Hello, we are team IDK from Chen Shaoman Catholic Secondary School in Hong Kong.
I'm Hugo, the hardware developer of the team.
I'm David.
And I am Zhang Yin.
We are the software developers of the team.
We have participated in different robotics competitions, such as RoboFest and soccer simulation demo competition. But this is the first time we participate in RoboCup Junior events. We participate in the RoboCup Asia Pacific competition in order to gain insight and obtain experience. Here is the introduction to our robot.
Arduino Mega 2560 Pro is the main controller of the robots, which acts as the brain of a human. It is stable and fast in data processing speed. Speedy executing the instructions of our program allows us to do specific tasks more efficiently. It is inserted on our mainboard and connected to different components. As the team description paper mentioned, we designed our own PCBs. Mainboard, IR sensor ring, and ultrasonic sensor ring. We use Altium Design to design them and order from companies after finishing the sketches. We solder them by ourselves. The mainboard is used for distributing the electricity from the battery to different components and connecting them by different physical paths, such as I2C and U out. The board's direction can be found by using the IR sensor ring. The IR board emits infrared radiation signals, and the IR sensors receive them to get the direction of the board. Compass is one of the important parts of robots. It indicates the direction of them. QMC5883L was chosen because its raw data can be transferred to the Arduino Mega 2560 Pro, which is the main controller on the mainboard, and its size and weight is also very suitable for this competition. It is small in size and lightweight. The ultrasonic sensor ring can emit ultrasonic waves to detect the distance between the robots and the wall of the field. We use it to prevent the robots from getting out of the field and do specific tasks. HCSR04, which can provide instant and accurate data to the main controller, was chosen. Let me introduce you to our motors. We chose to use brushed DC motors, CHR-GM25, BK370 from Chiha Motors because they are more powerful than the brushless DC motors, PM3510, that we originally chose. Although they have higher RPM, the torque is not enough to let our robots move smoothly. The motor was connected to the mainboard and controlled by BTN7971B. Instead of soldering wires between components, HT30 was used. When we find that there are some problems on the modules, we can just simply plug them out and replace a new one. This can help save a lot of time of repairing. We use the DL20 module, which is using Zigbee wireless technology as a communication module. It can communicate between two robots Arduino Mega 2560 Pro through UART protocol in 3,300 bits per second. Both robots can get the information of each other and react to attack or defense.
Arduino IDE was the main programming software. C++ language is used in our robots. Here are some implementations of our algorithms. Motor control. Vector resolving calculations are used to perform 360-degree movements. The robot is considered to be viewed in plan view. We resolve the velocity of a robot to two components along the two diagonal lines. The program converts the direction and speed requested by the main program into the speed needed for the motors of the two components with the aid of trigonometric functions. Ball tracking. IR lasers emitted from the IR ball are received by our self-developed IR ring. The ring consists of 24 IR sensors, which can detect the IR ball in all directions. We first find readings of the IR sensor with the largest reading and the two IR sensors near it. The two nearby values are used to determine which side the ball is closer to. The IR sensors were found to be easily affected by sunlight during daytime. We designed an algorithm to remove noises. We first scanned the analog voltage of the IR sensors for 833 microseconds continuously. Then we subtract the largest value from the smallest value. The difference is regarded as a filtered value of IR intensity from the ball.
Ultrasonic sensors. The trigger pin on HCSR04 is held high for 10 microseconds to send out pulses. We then record the time duration of the echo pin held high. Since we know the speed of sound in air vary are little in different temperatures and humidity, we assume it to be a constant of 340 meters per second. With a constant speed and recorded time, we can get the distance of ultrasonic pulses traveled. Innovative solutions. Multiple microcontrollers. We found that letting a single microcontroller doing everything causes great delay for it to run the algorithms for a soccer robot. So we give some software work to other microcontrollers. Different microcontrollers are arranged at multiple PCBs to specialize on a specific job related to their PCBs. Self-developed libraries. We learn how to use every open source module by looking into their data sheets. Then we write a library specialized for it. By doing this, not only we gain experience in coding, but we also learn a lot of working principles of sensor and actuators.
Last but not least, we would like to thank our teacher advisor, Mr. Watt, science teacher, Mr. Chin, and our coach, Mr. Kwok, for giving advice and guidance. Thank you, and we hope you enjoy the competition.